study today. Okay, let it open now. I don't know why it is not opening. Let me share again. This is not opening. Okay, let me do it on whiteboard now because I'm not able to share this file at time it's in Derive. So what is this Cauchy criterion for sequences of functions? Theorem. It's a very important theorem, like we did in the last lecture. That's the uniform using the uniform norm. It says that let Fn be a sequence of bounded functions, but we need bounded functions. That this is the something extra on it. Bounded functions on on A. Then we say that this sequence Fn converges uniformly to some function f on A if and only if for each epsilon greater than 0 there exists some number which only depends upon epsilon natural number such that we are using the norm of fn minus fm over the set A is less than epsilon for all nm greater than or equal to n epsilon. So this is why it is called the Cauchy criterion for sequence of bounded functions. And you see that we did the theorem using uniform norm, and that was also a necessary and sufficient condition for the uniform convergence of a sequence of bounded functions. And this is also a necessary and sufficient condition for a sequence of bounded functions. But this you can be used when you do not have any clue about the uh, existence of a limit of the sequence. You don't know the limit, pointwise limit, then you might it use, because then you only have to see check the size of the terms of the sequence. So let's try to write its proof. First, let us suppose that the sequence is uniformly convergent. Suppose that sequence fn converges to the function f uniformly on A. So what this means by definition of uniform convergence, it says that then for any given positive number epsilon, there exists some number. Let that number be denoted by k, but I'm writing it to depend upon epsilon half, such that what do you say, fn minus f, this is the uniform norm limit that I'm using here. The definition of uniform convergence is the functions are bounded. Norm of fn minus f is less than epsilon half for all n greater than or equal to k epsilon by 2. This is the equation. Now Let us look at now. Let us look at this number fnx minus fmx of mod. Okay, and now what I'm going to do, I'm going to add fx and I'm going to subtract fx out of this number. And if I do that thing, I'm writing it as fnx minus f of x plus f of x minus fm of x, where n and m are any numbers. And now if you use the triangle inequality, it will be less than or equal to fn of x minus f of x plus, you can write it as fm of x minus f of x by triangle inequality. So now note
सर
that
ये एप्सिलॉन बाई टू आएगा आई थिंक।
कहाँ पर
ये जो आपने यहाँ पे लिखा फॉर एनी गिवन एप्सिलॉन ग्रेटर देन जीरो, आई मीन अगर हमारे पास वो नंबर एप्सिलॉन बाई टू पे डिपेंड कर रहा है तो ये एप्सिलॉन बाई टू होगा शायद।
हाँ कोई बात नहीं, टू इज अ कांस्टेंट क्वांटिटी ना, एप्सिलॉन एप्सिलॉन हम एप्सिलॉन हम चेंज करते रहेंगे, टू कैन नॉट बी चेंज, टू विल बी द सेम थिंग। सो जब आप कहते हैं एप्सिलॉन बाई टू गिवन है तो दैट मीन्स वो एप्सिलॉन होगा, उससे कुछ फर्क नहीं है। इट डजंट मैटर, वो
ओके सर।
एप्सिलॉन को हम बाद में हाँ बाद में हम एडजस्ट करते हैं उसी को, क्योंकि टू इज अ कांस्टेंट, क्योंकि जब भी जो एप्सिलॉन है ना, तो आप इसको किसी भी कांस्टेंट से एडजस्ट कर सकते हैं, वो आपकी रिक्वायरमेंट है कम कैलकुलेशन में फिट बैठने के लिए। अगर आप एप्सिलॉन बाई टू नहीं भी रखोगे, लास्ट में मेरे पास जहां पर मुझे लास्ट में मेरे पास टू टाइम्स एप्सिलॉन आएगा तो भी कोई दिक्कत नहीं होगी, क्योंकि मैटर करता है कि एप्सिलॉन गोज टू जीरो तो एप्सिलॉन बाई टू भी जीरो हो जाएगा और टू एप्सिलॉन भी जीरो हो जाएगा, वो ज्यादा इंपॉर्टेंट है। ठीक है,
ओके सर।
ओके। सो लेट्स नाउ सी, okay, why it is not opening? It has some problem today. Okay, let me clear it. Then what I can do, I will clear it. So let us continue now with the proof. Now see this thing. Fn of x minus f of x has to be clearly less than from the supremum of all such numbers, fn of x minus f of x, where x is any number in A. And what is this supremum? By definition, this supremum is norm of fn minus f. So you have this inequality. So whether I take n or m, so this fn x minus f of x is going to be less than or equal to norm of fn minus f. Hence, we have norm of, I had begun not with norm, I had something else. Hence, now I am going to choose n and m to be numbers which are greater than or equal to n epsilon. I have taken that to be k epsilon by 2, and it is fn x minus fm of x, and I had that this number less than or equal to fn of x minus f of x plus mod of fm of x minus f of x, and as seen above, this has to be less than or equal to norm of fn minus f plus norm of fm minus f. And since the sequence is given to us to be uniformly convergent, and in previous equation you say that this number, whenever n and m are bigger than or equal to this number k, then this norm of fn minus f is less than epsilon by 2, and the norm of fm minus f is also less than by 2, so this is equal to epsilon. So what it means now, it means that whatever x you take, it means that whatever x you take, fn x minus fm of x is going to be less than or equal to epsilon. This means that this epsilon is an upper bound for this set, fn x minus fm of x, where x is any real number. So this is an upper bound for this set. If it is an upper bound for this, then supremum of this set has to be less than or equal to epsilon. And what is by definition supremum of this set is nothing but this is norm of fn minus fm, and this is less than or equal to epsilon. And this is what we needed to show that norm of fn minus fm is less than or equal to epsilon. Is it okay?
Yes, sir.
Okay, let's now look at the converse part. Converse says that whenever you have this situation where the norm of fn minus fm is less than or equal to epsilon for some after certain stage, then the sequence has to be uniformly convergent. So let's see. But I am not able to write today. Teachment has some problem. Let us check it. No, it's not opening. Eh, It is just giving me only one page today. Then I have to clean it every time. So let's look at the converse now. Conversely, suppose that uh, for each epsilon greater than 0, there is some number. What do you call that number to be? Let that number to be again an epsilon greater than 0, such that norm of fn minus fm is less than epsilon, less than or equal to epsilon भी चल सकता है, कोई issue नहीं है. For all n m greater than or equal to n epsilon, then we have to show that this sequence is a Cauchy sequence. So for this choice of n epsilon and n and m to be larger than m, let us see what happens. Fn of x minus fm of x, as you can see, this has to be less than or equal to supremum of all the such numbers, fn x minus fm of x in a, but this supremum is nothing but this is norm of fn minus fm, and this is always less than epsilon for all n and m greater than or equal to n epsilon. So what it implies? It implies that that is, you get this for a fixed x, you what you see that this sequence of numbers is a Cauchy sequence. This is less than or equal to n m greater than or equal to n epsilon. So that is to say that for fixed x, fn of x is a Cauchy sequence. It's a Cauchy sequence of real numbers. And now we have to use the Cauchy criterion, and hence by Cauchy criterion this is a convergent sequence. Hence by Cauchy criterion for sequence of real numbers, we have that the sequence is convergent, means the limit of the sequence exists. So that is to say that limit n tends to infinity, fn of x exists. So whatever x you take, ये लिमिट हमेशा एग्जिस्ट कर रही है, या इसको आप ये भी कह सकते हैं कि दिस इज अ पॉइंट वाइज कन्वर्जेंट sequence. So this means that this is a point-wise convergent sequence. This is true for every x. This is true for every value of x in A. Hence, uh, Fn is point-wise convergent. So हमें यूनिफॉर्म कन्वर्जेंस शो करनी है, ठीक है. तो यूनिफॉर्म कन्वर्जेंस के लिए हमें इसका लिमिट फंक्शन भी चाहिए होगा, तो हम लिमिट फंक्शन डिफाइन करते हैं. एक फंक्शन f from a to r as f of x is a number which is nothing but which is the limit of पॉइंट limit of this sequence at x. और ये लिमिट एग्जिस्ट कर रही है, और ये लिमिट यूनिक भी होती है, since limit is always a unique, so as this f is a well defined function. Okay, so you have this situation. Now we have अभी अभी previous equation में हमने देखा कि we have this inequality f m of x minus fn of x is less than epsilon for all n m greater than or equal to n epsilon. We have this situation. And also at the same time I might say that this is greater than or equal to, and I might write मुझे कोई दिक्कत नहीं होगी लिखने में less than है तो I can write it less than or equal to epsilon also. So what do we have now? Um, if I take a sequence, if I fix m for the brief time and let a n be equal to f m of x minus f n of x, okay, then what do we know? Then अगर अभी m फिक्स है जी, m चेंज नहीं हो रहा है, तो देन वी से क्योंकि एफ एन एक्स कन्वर्जेंट है, वी नो दिस थिंग कि एफ एन एक्स कन्वर्ज करती है f को, तो देन यू सी दैट कि सीक्वेंस ए एन जो है, सीक्वेंस लिमिट ए एन कन्वर्जेस टू एफ एम फिक्स है माइनस एफ ऑफ एक्स, this converges to f of x. Is it okay? And is it clear? m फिक्स कर रहे हैं, m नहीं चेंज कर रहे हैं, I'm just changing the n, m को फिक्स कर रहा हूँ, तो हर एक m के लिए you are going to get this limit to be fmx minus fx. Also you also let me write it here with different colors so that it is differentiable. Also note that 0 less than or equal to a n is less than or equal to epsilon for all n greater than or equal to n epsilon, and this follows from this equation. तो जब सारी टर्म्स एप्सिलॉन और जीरो के बीच में लाई कर रही हैं, तो इसकी लिमिट जो होगी ना ए एन की, वो भी लेस देन और इक्वल टू एप्सिलॉन होगी और ग्रेटर देन इक्वल टू जीरो होगी. तो दिस मीन्स दैट जीरो लेस देन और इक्वल टू, बट इसकी लिमिट क्या है? इसकी लिमिट है एफ एम एक्स माइनस एफ ऑफ एक्स is less than epsilon, or in particular you may write it that fmx, and this is true for every x का कुछ भी रोल नहीं रह रहा अब यहाँ पर, this is true for every x, minus f of x is less than epsilon for all x in a and yeah m, now m is greater than or equal to an epsilon. And now you see, you sum up what happens. You had some epsilon greater than 0 positive number, then for that choice of epsilon there exists a number n epsilon such that whenever you take m to be a number which is greater than or equal to m epsilon, then fmx minus f of x is less than or equal to epsilon for every choice of point x in a. And what is this thing? This thing is nothing but this is just the definition of uniform convergence of the sequence, and hence it implies that this sequence fmx is uniformly convergent. Is it okay? Is it clear,
Yes,
or
sir.
you have any question? Okay.
Yes, yes.
Okay. So let us now, what I'm going to do, I'm going to give you an example in which we will check out a given sequence is uniformly convergent or not. Let me take example, and in this example we have to show that this sequence of functions x square e to power minus nx is uniformly convergent. The sequence is uniformly convergent on this infinite interval 0 infinity. Okay, so let us take fn of x equals to, just for sake of simplicity, e to power minus nx, and I can write it to be x square upon e to power nx लिख सकते हैं, ठीक है. And if you fix x, then for each x to be greater than or equal to 0, x equal to 0 पे ये 0 ही होगी, तो x is greater than or equal to 0, you see that what is the limit of this number? x square upon, कोई बता सकता है कि इसकी लिमिट क्या है? Can anybody tell me what is its limit? Any guesses? You can make some guess also, because x is a fixed number. You might substitute x value of x, take x equal to 1. Don't worry. Take x equal to 1, that satisfies this x greater than or equal to 0. See what is the value of limit then. If you take x equals to 1, then the sequence is 1 upon e to power n. Then what is the limit of this sequence?
Sir,
0.
1.
Yeah, 0, 0, 0. Because e to power n डिनोमिनेटर में, तो e to power n जो होता है वो इन्फिनिटी को जाता है, तो डिनोमिनेटर में उसकी वजह से it will go to 0. So that means this is true for every x, hence it follows that the sequence has a pointwise limit. It is pointwise convergent and it converges to. So this gives that this implies that this sequence fn x converges pointwise to the function which is 0. Okay, this converges pointwise. Okay, do you have any questions regarding this?
Sir, but how it is uniformly convergent?
No, we have to still establish. हमने अभी यूनिफॉर्म एस्टेब्लिश नहीं किया है,
Okay, sir.
यूनिफॉर्मली एस्टेब्लिश नहीं किया, ठीक है। हाँ, अब यूनिफॉर्मली एस्टेब्लिश करने के लिए पहले व्हाट आई हैव टू शो नाउ, आई हैव टू यूज द यूनिफॉर्म नॉर्म, बट ये फंक्शन बाउंडेड है जी, ठीक है। आप इसका मैक्सिमम फाइंड आउट कर सकते हैं, तो फॉर मैक्सिमम फाइंड आउट, क्योंकि ये फंक्शन डिफरेंशिएबल है इस इंटरवल पे, तो मैं इसका मैक्सिमम पहले फाइंड करूंगा। तो डिफरेंशिएबल फंक्शंस का मैक्सिमम मिनिमम फाइंड करने के लिए आपको उसके डेरिवेटिव्स की वैल्यू फाइंड करनी होती है, जहां पर वो जीरो होते हैं और सिर्फ उन्हीं पॉइंट्स पे उसकी मैक्सिमम या मिनिमम वैल्यू अटेन होती है जी, ठीक है। सो I'm having some network problem today, or what is it? The internet is working well. Teachment is having some problem today. Okay, anyways, let us now look at the for the maximum value of this, for the maximum of f and x. This is the function e to power minus nx. That we have to start with the derivative of f of x to be 0, which implies that what is the derivative of x? You use the product rule. First it has to be 2x e to power minus nx, plus then it has to be x square into e to power minus nx, और फिर nx की differentiation होगी minus n. So this has to be 0. So this has to be 0 means you must have 2x minus n x square into e to power minus nx equal to 0. बट यू नो दैट एक्सपोनेंशियल फंक्शन कभी जीरो होता नहीं, e टू पावर माइनस एन एक्स किसी भी वैल्यू के लिए जीरो होगा नहीं, तो इसका मतलब आपके पास जो भी पॉइंट जीरो होगा तो वो होगा 2x माइनस एन एक्स इक्वल टू 0, बिकॉज e to power minus nx is not 0 for any x. So this further implies that x2 minus nx is equal to 0. तो यहाँ से x की दो वैल्यू होंगी, क्योंकि प्रोडक्ट है नंबर्स का, तो प्रोडक्ट में दोनों भी जीरो हो सकते हैं, बट या तो x इक्वल टू 0 होगा या आपके पास 2 माइनस एन एक्स इक्वल टू 0 होगा। तो या तो x 0 होगा, तो यहाँ से 2 माइनस एन एक्स से आप x की वैल्यू निकालो, इट इज 2 अपॉन n. So now you have two values, x equal to 0 and at x 2 upon n. तो x equal to 0 पे now at x equal to 0 fn 0 क्या है, fn 0 0 है, और fn क्लियरली पॉजिटिव वैल्यूज भी ले रहा है, ठीक है। तो सो fn at 0 cannot be the maximum. So clearly at x equal to 0 fn cannot have maximum, cannot have maximum value, cannot have maximum value. तो इसकी maximum value इसका मतलब 2 upon n पे होनी चाहिए, ठीक है। तो hence the maximum value of fn is attained at x equals to 2 upon n, and so अब maximum value क्या होती है? Maximum value means supremum of fn(x) where x lies in this interval 0 infinity, and we know that इसका supremum कहाँ पर attain हो रहा है? fn at 2 upon n, and this thing is nothing but this supremum is what you may write it as norm of fn minus 0. ठीक है, तो so what is this thing now? fn 2 to fn क्या x square, तो it has to be 2 upon n square into e to power minus nx, तो x की वैल्यू 2 upon n है, तो you see what is this thing? This is 4 upon n square into e to power minus 2. So now if you take n to infinity, what is the limit? Limit fn, fn equals n goes to infinity has to be limit e to power minus 2 बाहर निकालो, it is a constant quantity 4 upon n square, इसकी लिमिट बताएगा कोई मुझे? what is its limit?
0.
0, sir.
So its limit is 0. So we have this, and hence by the theorem of uniform norm, it follows that the sequence is uniformly convergent, क्योंकि आपके पास uniform norms की limit जो है it is going to 0, और वही आपके पास वहां पर criteria है theorem का. Theorem states that, let me recall that theorem, that it states that sequence fn of bounded functions converges to function f uniformly if and only if आपके पास fn minus f का जो norm है it goes to 0. ठीक है, as n goes to infinity. तो यहाँ आपके पास ये मिल गया. Hence it follows that the given sequence is uniformly convergent sequence on the interval 0 1. But ये ध्यान रहे ये interval 0 जरूरी है, अदरवाइज अगर आप इंटरवल में कोई भी वैल्यू 0 से लेस लोगे, फॉर एग्जांपल इफ यू टेक x equal to -1, तो यू सी दैट fn at -1 is x square का तो obviously 1 होगा, तो it has to be e to power minus n into -1, it has to be e to power n, और ये पॉइंट वाइज भी कन्वर्जेंट नहीं है बिकॉज e to power n goes to infinity as n goes to infinity. तो फॉर x लेस देन 0 इसीलिए हमने नहीं लिया, क्योंकि x लेस देन 0 पे ये यूनिफॉर्म कन्वर्जेंट नहीं है, इवन के वहां ये पॉइंट वाइज कन्वर्जेंट भी नहीं है. इज इट ओके?
Yes, sir.
सो एनी क्वेश्चंस?